Hello everyone, in this video we'll be discussing about the reverted gear trains. So already we have studied about the gear trains, which are combination of two or more gears to transmit power from one shaft to another. And under this classification, simple gear train, compound, reverted and epicyclic are coming. And in this video we'll be studying in detail about the reverted gear trains. So reverted gear trains are used when the axis of the input, that means the driver gear, and the last driven gear are coaxial, then the gear train is known as reverted gear train. So here you can see from this animation, so here we are having one axis where the shaft is attached, but this shaft and this shaft are separate but are coaxial. So this gear will be running and this will be coming in mesh with the second gear, and here is a common shaft which is carrying these two gears. So whenever this gear is rotating, this will also get rotated, and finally the power is transmitted to this one. So here the driver gear and driven gear are coaxial, and we will be doing the analysis of this reverted gear train to find the velocity ratio. So here you can see the schematic diagram of this reverted gear train. So here this input shaft, so this is another one input shaft and this is the output shaft, which are coaxial. So I can call this as the driver and this can be called as the driven. And so if you are numbering, this is the first gear and there is the common shaft on which gear 2 and gear 3 are coming, and the final gear can be called as the fourth. So here velocity ratio of this gear train means the omega 1 driver divided by omega 4, which is the driven, will be the velocity ratio. So here the gears 1 and 2 are coming in mesh. So there will be a common module for this gears. I can call it as M, that will be required. I will be discussing at the end of this case. And here 3 and 4 are coming in mesh. So there will be a module for that one, and I can call it as M dash. This and M and M dash need not be the same. So here since 1 and 2 are in mesh, I can write if the number of teeth on 1 is T1, this is T2, T3 and this is T4, then I can write omega 1 by omega 2 can be written as T2 divided by T1, and since 2 and 3 are coming on same shaft, I can write omega 2 equal to omega 3, and for the mesh between 3 and 4, omega 3 by omega 4 can be written as T4 by T3. So if you have to calculate the velocity ratio omega 1 by omega 4, then this will be the product of omega 1 by omega 2 and omega 3 by omega 4, because since this omega 2 and omega 3 are same, this will be getting cancelled and finally will be getting omega 1 by omega 4. And if you are observing, omega 1 by omega 2 is T2 by T1, and this omega 3 by omega 4 is T4 divided by T3. So here also this is the final expression for this velocity ratio, and here also in this expression all the terms, that means the number of teeth T1, T2, T3, T4 are coming. That means here also the number of teeth T3 and T4 which are coming on this T2 and T3 which are coming on the intermediate gears are having influence on the velocity ratio. So this is the way how you can find the velocity ratio for a reverted gear train, where the driver, that means the input and output gears are coaxial. And here also one more parameter I will be showing. Here the shaft 1 and 2 are having a center to center distance that you can evaluate, and that will be the sum of, this will be the radius of gear 1 and this will be the radius of gear 2. So R1 plus R2 will be the center distance. Similarly, you can calculate the center distance between these two gears, that is these two shafts, that is, and for that this distance will be equal to R3 and this much distance will be equal to R4. That means from here you can write R1 plus R2, center distance between the shaft 1 or the input and the common shaft is same as R3 plus R4, that where R4 is the, or fourth is the output gear which is coming on the output shaft. So here I can write R1 is actually D1 by 2, diameter by 2, R2 is D2 by 2 and R3 is D3 by 2 and R4 is half of D4 or D4 by 2. So from this you can write it as D1 plus D2 equal to D3 plus D4, sum of this diameters. And you are knowing that for gears, diameter is equal to the module into number of teeth which are coming. For example, if you are taking D1, then it is equal to, here For the meshing between 1 and 2, I am calling the module as m, and for the meshing between 3 and 4, it is m dash. So d1 I can write it as m into t1. d2 I can write it as same module m into t2, since 1 and 2 are having module m. And d3 I can write as m dash into t3, and d4 I can write as m dash into t4. This expression you may be requiring when you are solving problems. So d1 plus d2 I can write it as m into t1 plus t2, since module is common for those two gears which are coming in mesh, and it is equal to m dash into t3 plus t4. So this 3 and 4 are coming in mesh. So this expression you may be requiring when you are solving problems. So here we will be seeing a simple problem from the reverted gear train. So here we have a problem where shaft A and B are coming in straight lines, that is coaxial, and they are geared together with the help of this parallel shaft C. So that makes it a reverted gear train. The wheels connecting A and C, that means for their pairing it is having a module of 2 mm, and for the pairing at this between B and C, they are having a module of 3.5 mm. And here it is mentioned that the speed of B is lesser than 1/10 of the speed of A. That means if it is omega A and it is omega B, or I can call it as number it as 1, 2, 3, 4. It is mentioned that whatever be the speed of A, the speed of B should be lesser than the 1/10 the speed of omega A. So this, based on this, we will be making an assumption. We are knowing that 1/11 is lesser than 1/10. So based on this one, I can find, or I can assume that omega B is equal to omega A by 11, which is lesser than 1/10 of omega A. So this is an assumption. And shaft B, I can write it as speed of 4, and this A, I can write it as speed of gear 1. So omega 1/11 I can write. Or in terms of velocity ratio, that is the omega 1 by omega 4, I can calculate as 11. So this is an expression. So this we will be requiring later. And also from the previous discussion, we are having the center distance between A and C, that is d1 plus d2, half of this one will be same as d3 plus d4. So this is between the output shaft B and this parallel C. So this one expression you are having. So based on the previous expression, I can write it as m into t1 plus t2 is equal to m dash into t3 plus t4, where m is given as 2 mm and m dash is equal to 3.5 mm. Also we are having an expression or an information that the two pinions are having, here it is given, two pinions have each 24 teeth. Here pinions means the smallest gears which are coming in this one is known as pinion. So the gear coming on this shaft A is also a pinion, and also the gear this 3 coming on the parallel shaft C is also a pinion. So now we are having the information that is number of teeth on 1 is 24, and also the number of teeth on 3 is also teeth on 3 is also 24. So I can write this m is 2 mm, 2 into t1 is 24 plus t2 is unknown equal to m dash is 3.5, t3 is 24 plus t4 is unknown. So this one I can simplify, then I will be getting an expression in terms of t2 and t4. t2 minus 1.75 t4 will be equal to, right hand side will be 18. So this I will be calling as the equation 1. Now I will be taking this expression for velocity ratio, that is omega 1 by omega 4. So we have already discussed just before, omega 1 by omega 4 is actually equal to t4 divided by t3 into t2 divided by t1. This we are having. And here this right hand side is equal to 11. From here we are having. And this value of t3 is 24 and t1 is also 24. So if you are simplifying this one, you will be getting the product of t2 and t4 from the numerator will be equal to 24 into 24 into 11. That means 6336 you will be getting. And this equation I can call it as 2. That means now we are having two equations and two unknowns, that are t2 and t4. So now you can solve for this t2 and t4, then you will be getting the value. So when you are solving those two equations, you will be getting t4 as around 55.25 you will be getting, and that can be assumed as the number of teeth as a whole number, which is 56. And if you are finding t2, then based on this one you can evaluate this as 116 you will be getting. So now we are having the number of teeth on all gears. Already T1 is 24 and T3 is 24. Now we are having T2 and T4. So based on this, now you can calculate the actual velocity ratio. The velocity ratio is actually omega 1 by omega 4, which is equal to T2 by T1 into T4 by T3. So this is based on the actual number of teeth. Earlier we have made an assumption it as 11. So if you are finding this T2 is 116 into T4 is 56 divided by T1 is 24 and T3 is 24. If you are solving, you will be getting this value as 11.28. So 11.28 is the actual velocity ratio. The assumed velocity ratio is 11. Anyway, this value, that means if you are calculating, this is actually omega 1 by omega 4. So if you are finding this omega 4 is omega 1 by 11.28. That means anyway this is lesser than the omega 1 by 10. So this assumption as well as the actual velocity ratio values are valid. And here also you can calculate the actual center distance between these gears, that is D1 plus D2 you can evaluate if this is 1 and 2. So that can be evaluated by m into, so actual center distance is half of this D1 plus D2 by 2. So this will be equal to m into T1 plus T2 the whole divided by 2. So all values, m is 2 mm, T1 is 24, m is 2 mm per tooth, T1 is 24 mm, 24 number of teeth, and T2 is 116. So if you are substituting, you will be getting the center distance as 140 mm. So this is the final answer for this problem. So we have made an assumption for this velocity ratio, then we have calculated the number of teeth, then based on that we have calculated the actual velocity ratio, and finally we have calculated the center distance of these two gears also. So hope you understood this problem on this reverted gear train. Thanks for watching.